See you all here. So I'm Paul Graham, as Scott mentioned, from MATRIXX Software, and yeah, we create 5G monetization solutions. So what we'll be talking about, the point is to talk about our experience deploying in 5G and cloud, in the monetization space, put a bit of AI in there as well as we're on the AI stage, our experience, telco requirements, how we've engaged with the CNCF, that's the Cloud Native Computing Foundation and the Linux, the Kubernetes world, and the lessons that have been learned. So I'll go. We had a 4G charging server, and over the last 3 years, we've been migrating it into the 5G cloud space. And we've had to implement some of the 5G standards. We've had to move to the brave new world of containerization in the cloud, and then make it fully compliant as a cloud-native network function. That's something you might have heard about. The big buzzword at the moment is Kubernetes in cloud, and that's where we've had to move it to. All the 5G standards are now based on moving into the cloud, Kubernetes, REST interfaces, and those sort of things. But we've also got to have an eye on the past. So there is a amount of legacy stuff we've had to take into consideration. Our experience, so we had to assimilate an existing charging system, which is basically in a monolith. It goes on bare metal, deployed all over the place, but needs to be moved into the brave new world of 5G and cloud. So engaged in lots of trials and installations. As MATRIXX, we are a global organization. We do work in all geographies, and we're part of Dish, a selected vendor at Dish in the US, the big new 5G network over there. Companies like Swisscom, Telco in Australia, Hutchison Group, to name but a few. Considerable amount of experience, right? As a vendor providing the telcos, we have to work in just about every form of cloud environment you could possibly imagine. AWS, Azure, Google, and OpenShift from IBM on-prem. This is a constant learning exercise. When we're doing this, we can't go and find the book or Google how to do this. We're inventing this all the time ourselves. Lots of lessons to be learnt, how you do it. We are working with telcos which have very stringent rules and availability. What we found is there's a clash of kind of cultures here. You're going from telco, you want to move to web scale, right? Telcos are notoriously slow at innovation. If you look at between 4G to 5G at the moment, you get a bit more data, but really what 5G is promising is more innovative services. But you need to get there first. You need to get to 5G and get your networks out before you can do your self-drive cars or whatever you want to do. And that's the real challenge at the moment. How do you get to 5G in the practices of fundamentally the previous generation? Once you're in the 5G and cloud space, then you can move quicker. Those of us in telco know that if you do implementation, you're going to be stuck with a 6 months to a year project. It gets tested, and then you leave it a few years and you come back again. Innovation cannot happen in that environment, right? We want to get to an environment where we want to push things out quickly, and that's where we need to move to a web-scale culture. We talked about talent earlier on, and you want to attract the best talent into your innovative environment. And again, you've got to bring the talent over to telco, and you do it by adopting web-scale and cloud-type technologies. Okay, this is what we're up against. This is the new 5G architecture, right? In the old world, you'd have lots and lots of boxes all over the place, physical hardware deployed out in those data centers. Now everything's deployed in the cloud. This is containerized, and it's managed by Kubernetes. Okay, MATRIXX, our monetization solution, is the 5G CCS up in the right-hand corner there, and we work in that environment. I won't do too much in the details, right? I know this is overview rather than deep dive type technical stuff. But that's our challenge. We want to move into this environment. Now, what people kind of miss, when I put that diagram up there, okay, that's how you run a 5G. The point of putting it in the cloud is now there's an opportunity to build applications in there with the 5G infrastructure. In previous generations, there's nowhere you would get anywhere near an operator's data centers, machine rooms, and deploy your applications in there, the same space, right? Now, because you're deploying 5G networks into the cloud, the only way you're going to get the promise of that low latency is by deploying your applications in there with them, right? If you want microsecond latency for your AR application, or you've got some AI which you want processing instantly feedback, you've got to have that application in the cloud with your 5G core. And so there's more to this than just moving to 5G in telecoms, right? The opportunity for anybody looking at applications, or you want to develop your AI into 5G, is to be deploying your applications in that cloud with the 5G core. Right? And I don't really see that discussed much, maybe because telcos are still working on getting this rolled out, but your opportunity is to get in there, right? That core may be deployed in AWS, maybe in Azure, right? You can go out there, get some funding, develop applications that are going to be deployed there. Our challenge as MATRIXX is we drop that box as a charging platform, but that box is made up of lots of components. This has to be containerized and deployed. And it has to be done gradually. You don't want to be breaking anything, right? I mean, telcos it's not 5 nines availability. You're trying to do brain surgery on somebody who's running a marathon, right? You don't really have time to experiment and change. You've got to move it gradually. In charging, we're at the very sort of nexus of the network and the IT systems. And there's a good talk earlier from VP from Salesforce talking about the marketplace that Salesforce provides. Here in MATRIXX, we sit in the middle between that kind of marketplace where you want to be selling applications and services and the network level. And when you look at that diagram, you'll see things going to networks, but you also see interfaces into payment gateways, provisioning systems, CRM. So we sit right in the center there. And our challenge is to take the 4G OCS, move it to 5G CCS, keep all that in place, and then move to the dream of cloud, CI/CD, and more rapid innovation. But of course, to get to that rapid innovation, we have to do it using the previous generation processes before we get there. As I mentioned, we are in the telco space, and with telco comes a lot of requirements which you can't get away from, right? We do have 5 nines availability. That means you're offline about 8 minutes a year, and typically you don't want to go offline at all. We do have 50 years of legacy requirements to support. Over that time, a lot of business rules are being written into those systems, into the OSS, BSS. You can't scrap it and start again. You've got to bring it forward with you into 5G and cloud. I was once sat down. I built some software that probably still runs KPN's network in the Netherlands, and sat down in front of execs and explained, you get this wrong, you destroy our economy. A few hours outage in the telco space can knock, billions with a knock-on effect into the economy. So we have to get that right. It's highly regulated. It's not just, we're a monetization platform, so we have the monetization aspect of regulation, but we do have the telco aspect of regulation as well, which is identity, where we can store data, how long we can keep that data for. We have warehouses of CDR records which had to be kept for, I think, 3 or 6 months. And that has to be maintained in this new environment. And the problem we have, or the challenge, is in monetization, where we sit between networks and IT. We have to deal with, in deployment, many different types of cloud environments. The network department, it can be different than the IT department. The network department may have their chosen cloud supplier. And the IT department, or the groups within the IT department, the OSS, BSS, they may have their chosen cloud supplier. So it's kind of like a DMZ between networks and the IT and OSS, BSS systems. And that's another challenge we have when we deploy into the charging space. And also, anybody who needs to deploy an application into 5G between networks and IT, and your artificial intelligence, AI apps, ML apps, will have that as well. You may be connecting to a network, creating a data stream, acting on it in IT space. You will have that challenge. I think, Azure, AWS would like us to think that we're going to put everything into their space, but you do have deployments that straddle both sides. So migration approaches to cloud native. Okay, we talk about the cloud, but we've got to get there. We do see hybrid setups. So that previous diagram I showed you with all the boxes, some of those boxes might still sit on bare metal. Others might, like the latest interfaces, SBA, that might sit in the cloud. And over time, we would move those components across. So even in a single installation, you might have hybrid, some containerized in cloud under Kubernetes, other components on bare metal, and that will happen as you migrate. We always talk about the 5G apps coming in, but you've got to have this migration plan. Other strategies could involve building a completely new greenfield site and moving all the data across, but that typically doesn't happen, apart from where we have greenfield operators like Dish in the US, and also, additional cloud-native domains. So decisions you have to make when you go to 5G and cloud, right, and you're moving applications, is how rapid do you move to cloud? If you do it too slowly, you won't get there, and you'll lose out to your opposition, or the customers, the operators, would just move on to something else that's already there. But if you move too quickly, you may break something, or you might not have the maturity in your culture or the application. That has to be taken into consideration. If you're going to adopt a hybrid architecture, what's that going to look like? Which components do you put in the cloud? Which components do you maintain on bare metal and then move across? CI/CD approaches. Now, in telecoms, the utopia would be to move to a CI/CD approach, right? At the vendor, you ship your applications in, they go into a pipeline and get deployed into the network. As I talked about, we have 6-month projects based on lots of testing and before you get final deployment. We want that rapid approach, right? We want to have everything automated to be able to make a change, press the button, it gets put into the network. If you have that, you have your innovation, right? Telcos are slow to innovate because they have so many processes forced on them by the high availability and the ability they have to get things right. So we want to speed that up. If we can have pipelines of automated test and deployment, then we can update our systems quickly, and then it gives us the space to innovate. Moving between generations of mobile at the moment, you end up with faster data, better latency, but we want innovation. And we need to get there so we can have quick innovation. So we're not beaten by those web-scale companies who it's in their power to be able to innovate quickly. Companies like Google and Netflix, they're rolling out their applications quickly, right? They're innovating on a daily basis. We'd like to get there in telco. And where do you put your data? Of course, that's hindered by regulation. Some geographies will let you have it in the cloud, others won't. It's almost country by country. And that's also a limiting factor in how you can adopt cloud and move to it. This came from a previous, I was at KubeCon a few weeks ago where we really had a deep dive on this stuff. But the point is they're traditional functions, and these are kind of they stop you moving forward quickly. If you want to deploy 5G services, but you still got to have those traditional voice and SMS that come with every operator, right? They're a bit of an anchor on your movement, right? And the problem is we can go out to the community in the open source people and get various components, but they kind of miss out things from the legacy domain. And in telecoms, we need to make sure these open source components are there for us to stop, so they don't hinder our movement into 5G. And Typically, the traditional stuff is typically voice and SMS and things like that, right? You can go most places in the world and you can still make a voice call and SMS, send an SMS from your phone, right? It's still out there still, it's not going to go away anytime soon, so it has to be brought into the new world. In telecoms, there's lots of things going on, lots of complexity and things like state, which the cloud environments kind of avoid. Again, my point here is we have to bring forward these legacy systems into 5G and cloud. Okay, so other things we identified when doing this work is you need kind of bridging functions to take you from the old world to the new world. And so we need to go from like the 4G systems to the 5G systems. And we built something called the charging bridge. That bridge is, I don't know if you know, it's the Orwell Bridge, just off Ipswich, River Orwell. Relevance is, it's River Orwell, and not many people know that George Orwell named himself after that river. He changed his surname to the Orwell, so it's IT and surveillance. The relevance in 5G, right? Mass IoT and mass surveillance. The charging bridge, right? So the point of this is, even though, ironically, it's a component that was looking back into legacy, it was the first step of building reusable microservices to achieve the goal. So we end up with a microservice in the cloud to do SBA, which is the new interface into 5G core, and then you have the legacy interface into the old system. So it bridges between the 5G world and the 4G world. And these are the systems you need to take you forward quickly, right? You can't just take a forklift truck, pick up all your systems, dump it into 5G. You've got to have something that bridges between the two. So, in fact, a pure containerized CNF function was built to perform this bridging between the old world and the new world. And then it enabled us to develop microservices in the cloud ready for 5G. So this is kind of like a migration strategy where you start with your bridging function, and then you're building your necessary interface into 5G, and then you can move the whole thing across. And going back to that early diagram with the components in the middle, and all those networks and payment gateways and provisioning interfaces, that's the kind of thing you need to be building. And that's an opportunity for somebody, right? It's all very well building the new 5G components, but there's an opportunity out there to build those bridging components to help the migration between the two worlds. So where does that sit in our reference architecture? Well, okay, stripped out some of the 5G components, but basically your network providing all the data is a bit on the bottom. It controls the usage of the data, and you're bridging into your legacy platform. And you will need lots of these kind of components if you're going to deploy 5G and retain the value of your existing systems. So, 4G on bare metal in the old world and monolith bridge into 5G in the cloud. And already it kind of sums up what you need to be doing to get there quickly. I mean, people are talking about 5G and cloud all the time, but how we get there is still being dragged, right, by the lack of these kind of systems and ways of doing it. So in the cloud, this is how it looks like in the cloud. Each one of those is a microservice or container. It's managed by Kubernetes, and you just deploy it, and it maintains it between the SMSF, which is the 5G component that controls data in the 5G network, and the 4G CCS at the top there. I can briefly talk about AI opportunities and all this. You're on the AI stage after all. I'm talking about 5G. If you look at that diagram, each one of those boxes and each one of those networks is creating data. And all that data, it's one of the key points of the visionary aspect of 5G and the way they've designed it, is everything is designed to create data, which can then be put into your AI system, right? So The obvious one is system health. If you're collecting data over a period of days and weeks and years, and you look at growth, and you can determine at a single point, is your network healthy just by the feed coming off of it, the usage. That's very basic, right? And if it drops in comparison with a previous trend over weeks, taking into growth as well, then you've probably got an issue which you can deal with very quickly, right? Your AI system should be making that analysis, feeds into your network monitoring systems, and you've got a problem, and bang, you can sort it out. What we haven't discussed is one of the new concepts in 5G is slicing. And that's where you can purchase a slice of a network end to end. You get guaranteed quality of service end to end, but you want to know, are you getting what you're paying for? You know, so the AI can look at all this data. It can look at your personal usage on your network, because you've effectively got a virtual network through the entire system. Are you getting what you paid for? Are you getting the promised quality of service that the operator is saying that you're getting for your slice? And that's how charging will evolve. It will evolve into, are you getting what you paid for? Because you're slicing through a network, you're slicing into the radio, all those systems. You want to know whether you're actually receiving, and if you're not getting it, then okay, adjustments are required. I say the final point here is embedded AI applications into the 5G core. And in previous generations of telco, say you'd get nowhere near the main equipment, right? It's locked away in a bunker somewhere, it's in racks. You're a user of that network on the data side, because you get data into your network, but you don't get anywhere near the control aspect. And 5G promises low latency. And for things like AI and industrial control, all those kind of applications which people talk about. And the only way you're going to get that is by getting in there into the 5G network, right? Deploying in the same cloud. And the extreme is edge computing. So what you do, you deploy your service on the edge in the 5G core. So you get that the lowest latency possible. And you only get that if you develop and deploy your applications in the same cloud as the 5G core there, right? So that's an opportunity. If you're in the AI space and you're looking for something to do in 5G, then data feed off the network for system health, data feed to make sure you're getting slice guarantees, or control applications of augmented reality that need very, very low latency and being able to deploy it into the cloud with the 5G control systems. So as a company, we're involved, actually a leader in this. There's an organization called the CNCF, Cloud Native Computing Foundation. And if you're in AI and you want to deploy in the core, you're going to need to know how to do it and what you need to meet. So what we're doing is building a set of conformity tests, and you can take your application, you can run it up in the conformity test suite, and that will say that it can be managed by the containerization orchestration system, probably Kubernetes, and you can deploy it in there. So at the moment, if I said to anybody, okay, go and build me an AI application that sits in the 5G core, where would you start? You have to read a load of standards about like that to figure out. The point of the conformity test suite is it gives you reference points, a place to start, so you can build your applications and deploy into 5G cores, and then sit alongside those apps and be managed, the end-to-end life from cradle to grave of those apps and the containers. And that's quite powerful, basically. You know, there's nothing really out there at the moment that says, okay, if I want to work with telcos and build applications with telcos, where do I start? So there's thousands of pages of standards, but you have to be an expert to understand those standards. And this gives you a place to start. Okay, so winding up, lessons learned It's an evolutionary process to move to 5G in the cloud. We have years and years of investment in the rules and networks. We have to support the previous generations of the networks as we go forward. Logging and observability, that's how you look at your networks. Still a lot of work to be done there. It's one of those things that you think about at the end when you spin up your network. Oh no, I don't know what's going on in my network when it fails. That has to be adoption of cloud native. That's a cultural thing. Everybody in telecom is going to have to adapt to cloud and cloud native. And then trust automation is key to increase cadence. Right? We don't, in telecom, want to keep building out the next generation to give you a bit more data or a bit more bandwidth. We want to be building out quickly so we can innovate in that space and then monetize it. So that takes the end, and the road ahead is really, fill the gaps required by traditional telecoms, which is often missed. The industry needs to gain trust in the whole kind of rapid rollout process and get away from those years of implementation projects so we can increase innovation. Develop open source components, which is an opportunity for lots of people here that are missing, and enhance the conformance test process so it makes it easy for anybody on the outside in the web scale space to work in telco and 5G cloud. Okay, that takes me to the end. Any questions on that one?
Are there any questions from the floor at all? If not, then please thank you, Paul. We're out,
there you go.
We're out of time.
Thank you.
Right?
Okay, yeah.
Thank you, Paul.